Okay, if you can hear me, we are going to go over the practice exam. So if you have any questions, specifically from the practice exam, we can go over those. So I hope you have it and we can look at it. If you don't have it, it's up on Google Classroom. You can look at it there. So feel free in the group chat to start posting questions. And what I'll be using here, as you guys post questions, I'll be using my Google Keep. I'll just write out my explanations here so you don't have to stare at me the whole time. What I need you guys to do is to start typing up questions in the chat section. Again, guys, I need you to start submitting questions. You know what? I think actually you guys are probably submitting questions. I'm probably just looking at the wrong thing. So give me a second and I will start taking your questions. That's probably my mistake. There we go. Okay. Now I can see your questions. Here we go. Electronegativity, starting with electronegativity in noble gas configuration. From Kedora. Okay. Number 7 was about noble gas configuration. I remember. And Vesper theory. Okay, so let's start with noble gas configuration. That's number 7. Roberline, if you can find one of the questions on Vesper theory, I'll be happy to go over it. Look it up while I'm going over this guy. All right, so number 7 says, let's see here, manganese has a noble gas electron configuration of Ar4s2. So this is manganese. And just give me confirmation, guys, that you can see my screen. You can see me writing this out. Just give me yes, or we can see it. Just because I'm not 100% sure if you guys can see it just yet. Again, if you can, just write yes. We can see it. Just someone write that on there. All right, 4s2 3d5. So how do you get that? All right, so what you have to remember is that chart that we did earlier in the year. It goes 1s, 2s for all of the electron configurations. So if you remember this chart, you'll be all right. Oh man. Sorry, guys, I just messed it up. My bad. 1 second. Okay, good. You guys can see it. Awesome. All right, give me a second. I just messed up and I got to start. I think I got to start over here. Having technical difficulties. All right, I'm just gonna start over. Again, we're going to go over number 7 at some point here once I get this figured out. There we go. Okay, number 7. All right, it's all about the chart. So I'm just going to go right to drawing the chart. So we have S, P, D, F. This represents all the electron orbitals. S holds 2 electrons, P is 6, D is 10, F is 14. You got to go know 1s, 2s, 3s, 4s, 2p, and it goes on and on, but you don't have to know the whole thing. It's not necessary for the questions you're going to see on the test. That's 2. And if you're trying to correct me, guys, give me a couple of moments to catch up, because I got to go back and forth between your comments and what I'm writing. So this is 3D, 4D, 4. It's a 4, kind of 5D. That thing's messing up. 4D. There we go. And then F is 4F, 5F. And again, it goes on, but we don't have to worry about it. So the question was asking about manganese. The thing about manganese, they tell you its noble gas configuration is AR4S2 3D5. Argon, I believe, has 18 electrons. Let me get periodic table up really quick. And make sure I do this right. Okay, yeah, argon's 18 electrons here. And then you got another 2, and then you got another 5. So total for argon is 25. So you would have to count out, to know the electron configuration, you first want to look at this 18 is just the atomic number. It's a number on top when you look at the periodic table. So you can just bring up the periodic table from the web, or if you got a handout of one, you can look at it really quick and double check that. So it's 25. So if you were to write this guy out, you'd start with 1s with these arrows. So that's 2, 3, 4. Each P is 6. So with these 6 here and the 2 and the 2, you have a total of 10. 11, 12. And then we got another P. That's 12 plus 6 is 18. Then we have another 2. That's a total of 20 so far. And then D holds 10. We don't need all 10. We only need 5 from this guy. So you know that its orbitals are going to end in 3D and 4s, and that's what we see here. We see that ends in 3D and 4s. So that's what you look at when you look at the question. You want to see which ones does it end with. So you basically have to write out the whole configuration and see what the proper configuration is. And again, with noble gas configuration, you're using these noble gases as a shortcut, as a shorthand way to write out the whole configuration. So the end piece here is just using those last bit of electrons. All right, back to your questions. I remember someone was mentioning Vesper theory, so I think I might do that next. And then we'll get to balancing chemical reactions and inter and intramolecular forces. Melissa's asking about balancing. Melissa, if you can, look up a balancing problem on the test, on the midterm, on the practice, and then I'll go over that one. Roberline, if you have one specifically, number 12. You put number 12 on there. All right, so we'll look at number 12 next. Let's see where we're at. All right, so next is 12. All right, 12 is talking about, according to Vesper theory, the structure of the ammonia molecule is NH3, or NH3 is, which shape is that? So we'll go over a couple of Vesper shapes just to review it. First off, when you're drawing something like NH3, if you want to be able to draw out NH3, first thing you have to do is look at the valence electrons for each. The valence electrons are based on what group each element is in. So N, for example, is in group 15, so it has 5 valence electrons. Again, that's valence electrons, that's ended electrons. And one way we wrote that out a lot was doing the dot structures of them. So N is 1, 2, 3, 4, 5. Each H is in group, hydrogen's in group 1, so it has 1 valence electron. So you can look at these combined and see that NH3 has a total of 8 valence electrons. With that in mind, we can draw the shape. You always start with the least electronegative one in the middle. So that's nitrogen in this case. Hydrogen will be off on the sides. And then you need to satisfy the octet rule, so you can't just leave it like that. Hydrogen only wants 2 electrons, so each hydrogen in this molecule is happy, but nitrogen is not. It wants 2 more because it has 2, 4, 6. It needs 2 more electrons. So we're going to put 2 more on the top, and that is the structure of NH3. Now, NH3 is what we call an AB3E molecule. The E is represented by these electron pairs on the top here. That's the E component, and the B's are like the hydrogens, and the A is just that one nitrogen in the middle. An AB3E molecule is identified as trigonal pyramidal. Something very similar would be a trigonal planar molecule. So a trigonal planar molecule would be BH3. It's a little different. B is in the middle, just like in this guy. The H is on the side, just like in ammonia or in NH3. Boron is an exception to the octet rule. It's one of the only exceptions you have to know. There's really only 2. You have to know hydrogen, which only wants 2, and boron, which only wants 6 valence electrons. So this structure we have for BH3 is good. That's it. That's all we need. We don't have to draw anything else. That's it. Because boron only wants 6 hydrogens. That is all. Now they have that structure. That's what we call an AB3 molecule. An AB3 molecule is also known as trigonal planar molecules. So there you go. Next was balancing. Okay, let's see. So Melissa wanted to know about balancing. I'm sure other people want to. Number 11. I'll come back to number 11 in a minute. Derek, you don't even have this class. Why are you in here? You don't even have my class, man. Anyway, balancing. Melissa, again, if you can find a balancing problem, I'll be happy to just let me know what number is a balancing problem on the test, and I'll go over it. Keisha mentioned number 32, so let me hit that up, and then Sharif won number 11, so I'm going to do those next. So let's do 32 and 11. All right, 32 was electronegativity. Electronegativity is really easy. When you look at the periodic table, imagine this is the periodic table. There's noble gases up here, hydrogen's up here, whatever. There's 2 patterns you have to know. One is the electronegativity trend. The electronegativity trend goes this way, where you have the highest electronegativity. And let me write that a little better. And over here you have the low electronegativity. On the other end, or flipping it around, is atomic radius, which is the exact opposite. So when you're also down here, you have the all these molecules down here have a large radius. And all the molecules over here have a small radius. So those are the 2 trends you have to remember: radius and electronegativity. All right, the other question was 11. And going back really quick before we leave 32. So if you look at the elements, You just got to figure out what's the proper order. So if they're in a column, if they're in a group, just go by this trend and you'll be fine. For example, in group 17, I'm looking at it now, you have F, Cl, and Br. So what is their like if you were going from lowest to highest electronegativity, what's the order? Well, I mean, you just follow the trend. The trend goes this way. So it's Br is low, Cl is next, and then F is next. It's the exact opposite for radius, where you're low to high for radius. Oop. And that's for radius. All right, next is number 11. Miss Keisha was asking about number 11. And I gotta take questions from Keisha. Which of the following atoms has exactly 2 unpaired electrons? I think we went over this on most classes, but I'll go over it one more time. This is all about the periodic table. This is like just knowing the period, like looking at the periodic table. So they compare 4 atoms: S, Ca, Ga, and Sb. S. Okay. Starting with sulfur. Sulfur is in group 16. Let me write it above it here. Group 16, that 6 tells you it has 6 valence electrons. So you draw 6 little dots around. 1, 2, 3, 4, 5, 6. Sulfur has 16 valence electrons because the 6 tells you that. Calcium is in group 2. I think my computer just bugged out or something because it's not working. So I hope this isn't shut down. Let's see. Yeah, it's still working. And yeah, I'm looking at your questions. Yeah, you're gonna have a periodic table, absolutely. And Melissa, I'll come back to number 29, and Sandia, I'll get number 22. Sharif, for number 11, we corrected that. That it wasn't actually A, it was actually B. So once you see it's B, that should make sense. Google Keep is shutting down on me here, so I'm gonna have to restart. Second time it's done it. I would blame Google, but Google is the reason why I can do this live stream to begin with, so I can't complain too much. All right, so starting over with the question, we got S, we got Ca, we got Ga, and we got Sb. We already said the S has 6 valence electrons. Ca, okay, Ca is in group 2. That 2 tells you it has 2 valence electrons. There it is. Ga is over on the right side. It's in group 13. The 3 tells you it has 3 valence electrons. And antimony, or Sb, is in group 15. The 5 tells you it has 5 valence electrons. So which one has only a pair of them? There it is. It's Ca. Okay, so let me look back at your questions here. Number 29. Let me get to number 29. Then I'll get number 22 for Sandia. I'll go back and do 29 for Melissa. And then, if you guys have more questions, feel free to ask them. We got a nice group of people in here. We got 26 people in here. That's great. That's awesome, guys. After this, you can study for your second period exam that you guys have tomorrow. Okay. 29, number 29. So go to page 20 or number 29, everybody. Okay, so 29 is all about a balance equation with aluminum that reacts with copper to sulfate. You can see from the practice test, there's not a whole lot of balancing problems. Like the only balancing problems are ones where I show you an equation and you have to balance it. or you have to check which one version of it is balanced. So I try to keep them simple. We will do more difficult ones after the break. We'll review it, and then we'll do a little more difficult balancing stuff where you guys have to actually write in the coefficients and stuff like that after the break. So with 29, I believe the answer was B. So let me do a different reaction, something simpler. I'm trying to think about one of the ones that we did from the practice test or from practice. So let me look one up really quick, and we'll do a practice one that we can work with. Well, here's another one that's on the test, and let's just look how it's balanced. So again, 29 is about balancing. So this is a balancing problem to help with it. So another reaction you'll see on the test is KClO3 breaks down to KCl and O2. So the first note on this guy is remember oxygen. Remember you gotta remember the mnemonic. I bring cookies for our new home. Be sure to remember that. Everything here is diatomic, so they all need to have this little 2 here. All right, remember that. It'll help you. So we can see oxygen has a little 2. Anyway, so balancing this guy, I've been writing it out this way, and that's been helping people, so I'll just stick to that. So on the left, we have 1 potassium. On the right, we have 1 potassium. So potassium so far is balanced. On the left, we have 1 chlorine. On the right, we have 1 chlorine. So far, chlorine's balanced. We get in trouble with oxygen, where on the left, you have 3 oxygens. On the right, you have only 2 oxygens. So we need to increase our number of oxygens. The first thing you do is just put a 2 here. That would give you 4. And you should realize that that doesn't help you too much because you can't really put a number here to go from 4 to 3. If you were to increase this guy and put a 2 up here, that's great. That gives you more oxygens, but it gives you a lot more. In fact, it gives you 6. So now we got to go back over here, cross that out, and make sure we get 6. So we'll put a 3 here. And now that gives us 6. So far, that's looking pretty good with oxygen anyway. Now we got to go back. Since oxygen's all knocked out, we got to make sure everything else is fine. Be sure to double check everything. We can see here now we have 2 potassiums, so I'm going to have to put a 2 here to balance out these 2 potassiums. And we also have 2 chlorines, so I got to put a 2 here. Or this other 2, thankfully, balances out the chlorines. So these just working out oxygen help us balance out everything else too at the same time. So that's just a little practice with balancing problems. The ones on the midterm are not that bad. I try to keep them simple. They'll be more difficult after the break, after the holiday break. Okay, 29. I think we basically just did 29. Let's see here. Tyler mentioned 16, so I'll hit that up in a second. Let's see here. Yeah, the test is going to have similar questions as the packet. Absolutely. All right, so far, the last one's going to be 29. If you guys have any others, put them up here, and then I'll go over them. Right now, we're going to do number 29. Or, excuse me, not number 29, but there was another one. Was it 29? Yeah, we basically just went over it. Okay, 16, my bad. We're going to do 16 because Tyler was asking about it. All right, 16 is talking about charges for ions. That's easy. Because once you have the periodic table in front of you, that's going to be really straightforward. So let's write out the ions for number 16 that they give us. So 16 is talking about, I forgot what the answer was. I'll look over them. I can tell A is wrong because sodium and magnesium don't have, oh, it's at the bottom. Let me check it really quick. 16 is B. All right. All right, so 16 is saying that these are the proper ions. for each of these. So how would you know that is really the question. How would you know which one has the right ion sets? And then O2 minus. So basically the question is asking you, how do you know these are right? Okay, potassium, K, is in group 1. All right, that 1 tells you that the potassium has 1 valence electron. Potassium likes to get rid of that valence electron. When it becomes an ion, it knocks off, it loses that valence electron, usually shares it in an ionic bond, or excuse me, not shares it, but transfers it in an ionic bond. Like it'll transfer it with some other substance, it'll get rid of it. And as it loses that negativity, it loses that negative charge, it becomes a positive ion. And since it only loses 1 electron, it becomes a +1 ion. Now, similarly with SR, SR is in group 2, not that far from potassium. SR thus has 2 valence electrons. When it gets rid of them in a bond, it gives them to whoever, maybe like oxygen or something like that. When it gets rid of a bond, that's 2 negative charges. That's 2 electrons, 2 negative charges. So it becomes a +2 ion because it's losing 2 negatives. It's normally neutral. Like SR by itself is a neutral molecule, neutral element, neutral atom. So if it were to lose 2 electrons, it's going to become a +2 charged molecule. And then on the opposite end is oxygen, where you have this molecule that normally has 8, it's in group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, 6. So its options are to either get rid of all these 6 electrons to try to satisfy the octet rule, so it can have a total of 8. It's easier for oxygen just to gain 2 electrons. Like it could gain 2 electrons from strontium. Wherever it gains those 2 electrons, it doesn't really matter. It just usually it gains 2 electrons when it's forming a compound or when it's forming a stable molecule. When it gains those 2 negative charges, it becomes a -2 ion because it's gaining 2 electrons, 2 negative charges. That makes it -2. So basically, you want to look in the periodic table. You would look at those answer options at number 16 and say, okay, which one lines up with the right type of ion? It's really easy in the periodic tables. I think I actually have it on here somewhere. It's really easy with the periodic tables from this that you use for the tests. I thought I had them up here. I thought I had it up on here somewhere. Oh yeah, hold on. Yeah, I could have swore I put the periodic table on this Google Keep thing. Yeah, I guess it's all the way down there. Oh well. But with the one on that you're going to see for the test, it has ions right at the top of the table, so it makes it easier for you guys. Okay, questions. All right, I'm not doing 1 through 35. Get over that. Let's see here. So just did weight not 16, 19. Now you tell me. Great. Well, I just spent 3 minutes going over 16. All right, number 19. Let's do number 19 because Tyler got it wrong. Okay. Okay, so number 19 is talking about a phosphate ion. 19. All right, they talk about how many electrons are in the Lewis structure of the phosphate ion. So they're saying you have to draw out PO4 and see how many electrons there are in the whole molecule. So drawing this guy out, first you want to know how many valence electrons there are so you can know that it has the right number of electrons at the end. So phosphate is in group, I think it's a group 15. Yeah, phosphate's in group 15. So it has 1, 2, 3, 4, 5 valence electrons. Every oxygen is in group 16. So it has 6 valence electrons. Since we have 4 oxygens, I'll just draw those out really quick. And if you're not drawing this with me, you should be, because it's going to help you. It's going to help you remember this stuff. So I highly encourage you guys to draw this with me. There's a reason why I draw this stuff out so much. It helps you explain it and it helps you learn it. I hope that, when I draw it, you guys follow along. So if you were to count up all these dots, we got 6 valence electrons. We got another 6 here. We got another 6 here. 6 here. That's 24. Then we got 5 here. So we have a total of 29 valence electrons just from the elements. This -3 tells us we have 3 more electrons. So we have a total of 32 valence electrons in this molecule. So now we can draw out the molecule. Phosphate is more to the left, so it's going to, phosphorus is more to the left, so it's going to be in the middle. Oxygen is more to the right, it's more electronegative, so it's on the outside. We satisfy the octet rule for everything. Phosphorus is happy. The oxygens are not. They want their electrons. They want their 8 electrons. So we draw everything with 8 electrons to satisfy the octet rule. And if you count up all these dots and lines, you'll see that has a total of 32 electrons. So that's the Lewis structure of it. Or you use the Lewis structure to figure out the problem, to count up the number of electrons it has. So the answer's got to be C for number 19. All right, what we got next? What Vesper shapes do you have to know? Just the basic ones, like the ones in here. You got to know planar. You should know NH3, BH3. You also want to know tetrahedral. I'll show you guys tetrahedral really quick because it's another shape you want to be familiar with. This guy's actually tetrahedral, I think, but anyway. Tetrahedral, like the Vesper shapes. The one tetrahedral, stereotypical one that you should know is methane. That's methane. We call that an AB4 molecule, tetrahedral. So not too much on Vesper shapes. It's not that bad. Hi, Daniel. How's it going? There we go. Okay, so it seems like you guys are pretty good here. A whole lot of other questions. Because I'm not going over all of them, that's for sure. All right, Tyler's saying 22 through 24. So I think those can be the last ones I go over. 22 through 24. Or 22, 23, 24. Those will be the last ones I'll go over. We'll go with that. I cannot teach ACE Chem. No, you have an ACE chemistry teacher. You're good. All right, 22 first. And then I'm calling it a night. 22, 23, 24. And I'm done. All right, which of the following is no dipole? This is a weird question. Kind of a tough one. You basically have to figure out which one is not polar. Your job is to figure out which is non-polar. That's what they're saying. If it's non-polar, it means it has no dipole. So you are looking for the molecule that's non-polar. The non-polar molecule is going to be the molecule that is unbalanced. And what I mean by that is basically you look at it and you say to yourself, it has an unbalanced amount of charges. The charges are not evenly distributed. And it's basically symmetry. So the correct answer is carbon dioxide. So the first pain in the butt thing here is that you have to be able to draw out the proper Lewis structure for carbon dioxide. So that's the first annoying thing that you have to remember. And then you have to be able to look at carbon dioxide. And really, it's all about where the electrons are. You can see there's more electrons on the outside, just free electrons. So that makes the ends negative. Looking at this molecule, you can see that the ends are negative. Each has its own end. Each has its own negativity on each end. If one end was positive and the other end was negative, it would be polar. It would have like a dipole. But it doesn't. I just made that up. That's not realistic with this guy. This guy actually has a negative N on each side. I know what you guys are saying. You guys are probably thinking, oh, this thing looks like a face. Like if you put a mouth here, it probably looks like a face for like a guy with glasses. But you guys don't know what you're talking about. Like you guys have such an imagination sometimes. Anyway, so this is a non-polar molecule. And that's basically what the question's asking you. Just to compare it really quick with one of the other molecules that are polar. Let's see, like NH3 or CCl4. Or excuse me, that's the wrong one. It says no typo. We're still on 22. Like NH3, or let's go with the weird one at the top. CN or HCN, which based on the H being in the front, you should know this is an acid. All right, because the H is right there in the front, that tells you it's an acid. This is called hydrocyanic acid, I think. Anyway, this is the proper structure for this acid, and then it has a couple electrons right here. You can double check that by looking at the valence electrons. So 1 valence electron, 4 valence electrons, 5 valence electrons. Add all those up, it should have 9 valence electrons. And you can see this guy has, well, let me double check that because that seems, carbon has 4, nitrogen has 5, hydrogen has 1. So it should actually have 10, excuse me. I counted that wrong. There we go. 10, and yeah, this guy has 10, 8, 9, 10. So this is the proper structure. So the reason why this guy is polar is because this end is negative and this end is positive, and you can see that there's no electrons here. No electrons means it is positive. Whereas this guy has electrons, so it's negative. So this whole molecule has a dipole. And what you could do is you could draw an arrow, wrong way. You could draw an arrow right here, like that, showing that it has a dipole. Let me just check let's see here. So next, oh, that was 22, so next is 23. All right. And I'll leave this video up in case you guys want to watch it, or if you have someone, if you know someone who missed it, you can tell them to watch it. It'll be up there. It'll be out there. Okay, so 23 is talking about the Lewis dot structure, of which one shows only one unshared lone pair of electrons. So basically, we just got to draw the Lewis dot structures of all of these. All right, chlorine. Here's the dot structures for chlorine. Chlorine is a part of the I bring cookies for our new home. So chlorine is always paired up like this. So like if chlorine's in a reaction, it usually looks like this. You can see that chlorine has a bunch of extra electrons. So that's not the answer. NH3 we drew out earlier. And if you didn't draw that before, you can see this molecule is in a bunch of questions. So you should draw it out a couple times. You can see NH3 is actually the answer because it has this lone pair of electrons, just a pair of electrons by itself at the top. So it's got to be the right answer. The other ones are wrong. Let's look at them really quick. Nitrogen is also part of the I bring cookies for our new home. Mnemonic. Here's what nitrogen looks like by itself. You can see it's 2 of them. It has 4 or 2 pairs of electrons on the out, so that can't be the answer. And then CCl4. Well, CCl4 has tons of electrons on the chlorines on the outside. All these chlorines want electrons. So that can't be the answer because it has a bunch of pairs of electrons floating around there. So this guy's the answer because it only has 1 pair of electrons in the end or on it. All right, last one is 24. Okay, so we have 2 molecules. This guy has a boiling point of 78 degrees Celsius, and the other guy has a really low boiling point of negative 24 degrees Celsius. So why? Why do they have such a large boiling point difference? It's all about this guy right here. This guy causes hydrogen bonding, and hydrogen bonding brings up the boiling point, increases the boiling point. All right, hydrogen bonding increases the boiling point. Hydrogen bonding can be caused by oxygen, nitrogen. Mainly those are the ones we see that affect hydrogen bonding. Let me draw them up here so I have room here. Oxygen, nitrogen, also fluorine can cause hydrogen bonding, but you rarely see that. The guy down here, he might be polar, maybe. I don't think he actually is. If he was, the only thing he would have would be dipole-dipole forces, which can bring up a boiling point, but not nearly as much as hydrogen bonding. Hydrogen bonding is the strongest intermolecular force. That's one thing I am pretty sure is on the midterm. I don't remember off the top of my head, but you have to remember that hydrogen bonding is the strongest force. In the middle is dipole forces. And at the end, all molecules have London dispersion forces. That's the lowest intermolecular force. The weakest one, hydrogen bonding, is the strongest one. You have to be able to identify when something has hydrogen bonding. Hydrogen bonding is caused just by the fact that it has OH. Dipole-dipole forces is caused by the fact that it's polar. And everything has London dispersion forces. Okay, if you guys have any, yeah, period 7s is Thursday. So tomorrow is just period 2. Tuesday, is period 1 and 3. Wednesday is 4 and 6, and Thursday is 5 and 7. I feel like, and if you guys watch this review, it should help. I can take more questions in class if so I see some other questions here. Dalton's law, Charles' law, Gay-Lussac's law. Yeah, you should know the laws. You can see that number 30, 33, 34, and 35 are about those laws. If you really still don't get those, you can ask me in class for the midterm. Significant numbers or figures, that's not really on the midterms. We don't have to worry about it too much, luckily. Let's see. 34. Robert Lee mentioned 34. What time is it? It's 8. Let me look at 34. Yeah, I'm pretty sure we did 34. All classes did 34. I feel like not everybody did 30. Oh, yeah, we should have done 35 too. And 33. Yeah, I'm pretty sure we went over those in class. I think everybody did them. And yeah, you're welcome, guys. I appreciate you guys coming up and showing up to actually watch this thing. So if you have any other questions, you can just ask me in class. Study for tomorrow. Be ready for your period 2 exams. Let's see here. I'm pretty sure that is it. Yeah. If you guys, if anyone missed this, it'll be posted up there. That's it. All right. Good luck tomorrow, guys.